Okay, we want to go through and generate G-code to do this facing operation. This is the same facing operation that I went over in the facing tutorial. It's just a continuation of taking this to the machine and actually doing it. So, first thing we want to look at when we get ready to export this NC code is to see what post processor we're working with. Down here in the bottom right hand corner, you should see the post processor. It should be right to the left of your crib. Here's my new crib that we created earlier, and here's my post processor. I'm using the Analam 6000 Revision D because that's what our machines in the shop use. If yours says something different, you need to change it. In order to change your post processor, you click on the post processor that's listed here. Brings up in this post options. You can hit browse, and this will bring up an explorer to point to your post processors. Now, on Butler's computers, these post processors are typically located Program Files, Delcam, FeatureCam, Posts. You may have to go up a couple folders to get to FeatureCam, then go back down Posts to locate these post processors. There should be 3 different ones that we use in our shop. Analam 6000 for our CNC centers, Fanuc 20T for our CNC lathe, and Flow WaterJet Pro for our water jet. So click on the post processor that you would like to use, hit open, and something else that we want to check, we are doing a facing operation, so that means our UCS is in the bottom of the part. We want to check our tool change location. If you run your simulation and you're getting a gouge and you can't figure out why, check your post options. Make sure your tool change location is well above the part that you're milling. Default, I believe, is set to 1 inch. 1 inch on Z height is in the middle of this block. So yeah, you're going to have some gouging because the tool is going to try to change itself in the middle of the block. Doesn't work. So you need to make sure you change your tool location to something well above the part. So I have mine set to 7. That's 3 inches above the part. That's plenty. Hit OK. Okay. So now we can run our simulation just to verify again. And after our simulation is ran, we can hit our Details tab and go through this Details tab to make sure everything looks right here. Things we're looking for in this Detail tab is material type, stock size, operations, make sure all your Z-inks are set, and make sure all your tool numbers are correct. So this first portion up here is going to be your stock size, your material, and the time that this program is going to take to run. So it's going to be 1 minute 37 seconds. Here's our stock size, and then here's our material. Looks good. So let's move on down to operation 1, which is a face, which is a roughing. So we're looking at tool number 1, which are, if you remember back from our tool manager tutorial, we set our face mill as tool number 1. So that looks good. We are going down 1.25 inches in 10 steps. So that's about 0.125 per step. Excellent. Operation 2 is a face. We're going 20 thousandths. 1 step. Looks good. So everything on this op list looks good. If you see something wrong here, let's say your tool number is wrong. To change your tool number, go back to your op list, double click your tool, double click face mill, or whatever tool you have on there, hit overrides, and this is where you change your tool number. If you are still having difficulty with this, rewatch the tutorial about the tool manager and tool cribs. It goes through all the steps on how to create a tool crib and how to set tool numbers. Do yourself a favor and watch it if you're still having difficulties. Okay, so we set our tool number is correct. If your Z-ink it looks wrong, again, double click on rough. There's your Z-ink. Change your Z-ink. Set, apply, okay. Rerun your simulation. Whenever you make changes to your part, you have to rerun your simulation in order to get the latest NC code. So after you've done all that, we can visually check our UCS, and we can hit our NC code tab. And this is going to be our G code that we send to the machine. Now, I don't expect you to know what all those codes mean. I just expect you to be able to pre-check your program to make sure your Z Ink is correct, your tool numbers are correct, your UCS is set up correctly, and it actually generates G code. Okay, so we've done all our checks. So now we need to save our code. So we can do this one of two ways. We can come over to the left to number 9, NC code, or we can go to File, Save NC. I tend to use the NC code button just because it's right there on the screen. It's one less click. So we have our NC code box. The one that we really want to pay attention to is this third one down, Save the NC code on my computer's disk drive. So you click that button, and then you can click Save to Directory, and this is probably where you're going to put in your thumb drive. I'm just going to put it to my desktop. NC program name. You want to name this something that you will know you'll know it's yours. So you might do your initials and a descriptor. Has to end in .g. You cannot delete the .g. You have to make sure .g is on there. Otherwise, it's not going to come out correctly. So make sure you do not delete the extension .g. Down here under selection, you can pretty much uncheck everything except for NC program. That's the only thing that we were really worried about in this box, so that's the only thing that needs to be checked. So we have your directory that you're saving to, you have your program name with your initials and a descriptor of what it is with a .g, and then you have NC program checked, and then you can hit OK. And it's going to tell you output is written to the place that you pointed it to save. Okay, now that you have your .g, you can take that and you can load it onto the machine. In my shop, we have a network drive that will drop it on in order to pull up to the machine. So again, in review, we are looking for, under our details list, to make sure time looks okay, your stock size is correct, the correct material. Under each operations, make sure your Z increment is set correctly, make sure your tool numbers are set correctly, and make sure your UCS is in the correct spot. Again, the only time we set our UCS to the bottom of the block is when we're facing. Any other time, we set our UCS to the top of the block. Make sure you know that. Check to make sure our NC code has generated. If you make any changes to your program, rerun your simulation. Once everything looks good, you can come over to NC code, save NC code on my computer disk, point to the directory that you want to save to, often your thumb drive, NC program name, name it something descriptive, initials, descriptor, .g. Selection, the only thing you need to have checked is your NC program, and then hit OK. And it says I already saved this. So I'm just going to hit yes, and then it tells you it's saved the .g file to the directory that you pointed it to. So that is how you generate G code in FeatureCAM.